During a fireworks display, a shell is shot into the air with an initial speed of 70 meters per second at an angle of 75 degrees above the horizontal. The fuse is timed to ignite the shell just as it reaches its highest point above the ground. Calculate the height at which the shell explodes, how much time passed between the launch of the shell and the explosion, what is the horizontal displacement of the shell. So we have got a shell that is thrown like that. It's actually timed that by the time it reaches this point, then it explodes just at the maximum point. And this is the horizontal range. This is the height, maximum height. First question is we want to calculate the height at which the shell is going to explode. That is the top there. So we can simply say 2gh is equal to v squared minus u squared. And this will be 2. Because we are going upwards, the g is going to be negative 9.8. We don't know the height. That will be equal to the final velocity on top is 0. Initial velocity in the y, the velocity was 70, so sine the angle is 75. This is supposed to be squared. So this is going to be 19.6 h is equal to negative 70 sine 75, and then the answer you square it, you get 4571.762239. Divide both sides by 19.6, which is a negative sign. The height is going to give us 233.25 meters. How much time passed between the launch of the shell and the explosion? Still remember the explosion is happening at the maximum point. So we can simply say V is equal to U plus GT. The final velocity at the maximum point is 0. Initial velocity, this is still in the Y, that is 70 sin 75. G is still negative because it went upward. So take it this as 9.8 T is equal to 70 sin 75. So divide both sides by 9.8, so that will be 70 sin 75 over 9.8. The time is going to give us 6.899 seconds. What is the horizontal displacement of the shell when it explodes? Now, we don't want the range for this question. We want the horizontal displacement of the shell when it explodes. So we want this distance because explosion is happening at the top. So let's say it's a small r. So we'll say small r, which is half of r, is given by Vx times time, and this is not the time of flight. This is the time taken to reach the maximum point, because the time of flight we could have multiplied this value by 2 when we find it, because the time of flight is the time taken to move from the bottom to the top and then back to the bottom. So this will be the velocity in the x, that is 70 cos 75 multiplied by the time, which is 6.899, and this would have given us 125 meters. That's the horizontal displacement.